Hello everyone, hope you all are doing great. This is your UGNX trainer Jyotiranjan Singh from Skyy Rider Institutions, welcoming you on today's session of UGNX or Unigraphics NX. Okay. In today's session, we'll be knowing about the product design process, or we can say product design, like how, from where our product designing will be starting and where it will be ending. Let us see that first. Like product designing process. Okay, product designing process means for designing any product, or we can say for manufacturing any product, what are the process it undergoes, like from, like I have said you, or you have learned about that, for product development lots of processes there, like from official work or documentation to designing, drafting it, analyzing it, manufacturing it. That is total the product designing, or we can say. So what are the product design process? So synthesis means here all the conditions of the market, or all the official documents are done over in synthesis, like the market conditions, what are the material will be used, what is the manufacturing process the product will be undergo, what are the material will be using, that will be coefficient, that will be cost efficient for us and as well as for the buyer, as well as the market condition, what is the previous and present market condition, what is the customer demand. Okay, like in the market, what is the customer demand, that will be analyzed over here. Like all the official documents will be done in this synthesis. Then modeling means sketching or 3D solid modeling. Okay, we'll be doing the sketching part also over here, like freehand sketches, wireframes will be generating over here, and if that product will be go on surface modeling or sheet metal modeling, if the product is designed in which modeling it will be more effectively done, so we'll be seeing over here. Then we'll be going for assembly. There will be analyzing the thing, okay, or we can compare the thing, or we can say we can see the matchings of our holes. If two holes are there, they are matching in the exact point or not. For that, assembly is used. Kinematics in a sense will be simulating our system, okay, like whatever will be producing, that will be simulated over there, so that we'll be seeing about the clearances and all that. Okay, then at last in the CAD we'll be having drafting. Okay, drafting in a sense, like we'll be giving a proper diagram to our manufacturer that this is our outlet of the product, you prepare the product like that. That is why drafting is used. Then optimization in a sense, analyzing things. Okay, like the product will be designing, that is will be analyzed, volumetric analysis, fluid dynamic analysis, everything, or static analysis will be doing over there. Okay, then at last manufacturing where our materials will be subtracted or added, which will be more efficient, that will be doing. So let us see what is synthesis first. Okay, synthesis is the market conditions. First is market conditions, like what is the market condition of the product. Okay, like previously what is the market condition, now what is the it is the analysis of our product, like from where like previous we have the product, that is what is the previous market condition, then we have modified that, and now the modified item, what will be the market conditions, whatever we are designing, what will be that market conditions, and in the future if we will be reverse engineering this, so what will be its like further market conditions will be seeing over there. So it is mostly analyzing the market, okay, like, or the customer demand, we can say. The next is customer demand. Okay, like what is the customer demand or the customer need. Okay, because most of the in our basically in India we like need some like that strength, cost efficiency, and it will be durability will be more. Okay, like we can say it will be looking beautiful, and it will be less in cost, and also it will be most effectively. That was we are looking in our India's situation. So for that, analyzing, the company will be analyzing that what is the customer need, which material will be done. Okay, like he'll be analyzing each and every aspect of the customer. Okay, then we'll be having components and materials. Okay, like which what are the components will be prepared for our manufacturing, like which components, how many types of components will be there, what are the materials will be used, so that it will be a fine product will be generated, as well as analysis and everything will be matching on that, and Also the customer demand, whatever the customer demand and market condition should be there, that will be suitable for that. So and how many type of components, like we have designing this cylinder head, okay, like how many like total engine block we can say over here. So how much thing like piston, crank rod, crankshaft, then we'll be having bulbs over there. So these are the components that will be doing in the paper, that this much components are needed, so we'll be manufacturing according to that. Then is production method and cost. Okay, what will be the production method, like which will be cost efficient to us, so that in a low process, okay, low production process, will be manufacturing things so that our cost efficiency will be low, and how much the cost is, like in company will be decreasing the cost, okay, that will be suitable for the company. So that's why the production method and cost is most important in the synthesis process. Then next is the modeling. Okay, modeling is creating the desired structure in CAD system. Okay, now previously what you are doing in the drafting sheets, okay, in your engineering you must have done in the drafting sheets, okay, the designings. So here in the CAD system we will be modeling it, okay, we call it solid modeling. So first we'll be going to the sketcher workbench, then sketcher workbench will be creating or we can say in a paper we'll be having a freehand sketch, okay, like a little bit of dimensions we'll be giving, then we'll be having doing the wireframe modeling. Wireframe modeling in a sense, like in the paper, first initial two steps are in paper we'll be doing. Wireframe modeling means like some simple lines will be drawing, like this much distance will be taking for this thing, and will be generating it. Then when it will be transported into CAD system, there will be seeing it will be done in the surface modeling thing or solid modeling thing or sheet metal thing, whichever will be less effective or we can say will be easy for designing, that method will be doing. Like a very complex component is there, okay, we will be doing it in the surface modeling, which can be done in the solid modeling. So there will be planning. So where solid modeling is used, where thickness is below or we can say less than 6 mm or greater than 6 mm we can say. Like here it is a little bit of wrongly written, so it will be thickness will be greater than the 6 mm, or like in solid modeling where the thickness is greater than 6 mm, we'll be using solid modeling over there. Then surface modeling. Surface modeling where thickness is negligible, or we can say where component is very much difficult to do in our solid modeling, there you will be using surface modeling. Then sheet metal where thickness is below 6 mm, okay, below 6 mm up to 3 mm we can say our sheet metal will be there, okay. That how we can manufacture our things in this type of categories. Then we will be having assembly and modification. Here it is used to see the parts are matching or not. If you have two products that are exactly matching or not, that are coinciding exactly or not, okay, or that are aligned properly or not, that is used to see assemblies. With respect to that, we will be changing it. Like if two holes are not matching, little bit of error is there, okay. So what we'll be doing, again we'll be going for software part or 2D modeling part, then again they will be modifying it, and again we'll be seeing its assembly, so that it will be, if it will be exactly matched, then we can have our products ready, okay, or go for next part. So it is also used for sharing the clearance and clashes. If two parts will be intersecting, okay, like there will be clashes on that, so to avoid that clashes we'll be seeing its assembly. If it is clashing, then we'll be modifying each and every aspect, then we'll be producing it. That is why assembly is used, or we can say it is the modification process, okay, for modifying any part or for analyzing any clashes between them, we'll be using assembly workbench. Then we'll be using kinematics one. Kinematics in a sense, here will be like simulating every parts, okay, like exactly it is moving in the same respect what is in our plan, that is exactly moving or not. If any clashes or any clearance is present, much clearance is present, like our desired clearance is present or not in that, if it is colliding with anything or not. So that is how kinematics is done. Or simplification, you can see if this rod will be bended over here or got stocked on this, so it will be not moving. So this is used for kinematics thing. So whatever the things will be rotating or moving over here, so the exact part it will be done in the physical also. Then we will be having drafting. Okay, drafting is representation of object in 2D of the 3D model. Like the 3D model we have, like this, the cylinder we have over there. So that is done for 3D. So to do in the 2D, to represent it in the 2D, drafting is used, where we will be giving GD&T, material specification, sectional view, bill of materials, then tolerance limits. There will be giving it to the process. Okay, like the manufacturing will be getting a exact knowledge on the product, so that he'll be modifying, or he will be generating the products, or he'll be manufacturing the products with exact length, precision or accuracy. It will be making from reading this drafting sheet. So drafting are generally done in two types, that is generative and interactive. Interactive means the exact view we are seeing, like we are seeing a part, okay, like in the real world we are seeing the part, that exact thing we will be doing in our CAD software, okay, or we can say that exact thing we will be putting in the system, that is called interactive. And generative means the part you have done it already in the modeling session, okay, like you have done it in the modeling session and that we are bringing to the drafting sheet, that is called generative. To generate from one product, the draft, to generate the 3D model to 2D, okay, there you will be using drafting. And to see the real world object and doing that 2D object, that is called interactive. Okay, then the last part of CAD and CAE is CAE. So CAE is for analyzing thing, like what are the, how much pressure it can, like this piston head we have over here, piston we have over here, so how much heat it can resist, which material will be best for like whatever heat we are giving, which material will be used over this, then how much volumetric efficiency it will be having. So this all static analysis will be done over here, then structural analysis done over here. So this all kind of analysis is done over here to see, like to analyze this thing, okay, so that the product will be having a long life. That is how this analysis is done, and it is the most durable on that. That is why this analysis is done. Then at last our manufacturing is done. Like in the manufacturing, what is the manufacturing? That is converting a raw material to a good finished product or desired product, we can say. Whatever you have designed, we'll be sending it to the machines, like in form of G codes or M codes, or we can say we will be giving the draftings to the manufacturer. The manufacturer will be taking the required specifications of the material that we have provided him, then he will be doing any type of manufacturing, that is additive or subtractive. If it is be effectively done in the additive type, then it will be doing in the additive type of manufacturing. If it will be done in the subtractive kind of manufacturing, it will be doing in the subtractive kind of manufacturing. Like additive is where the materials will be deposited and it will be forming our desired product, okay, layer by layer our materials will be deposited on the things and our desired product will be generated. That is called additive, or adding material to get our desired product, that is called additive manufacturing. And from a component, if the material will be removed, that is called subtractive kind of manufacturing. From a component will be removing material to get our desired product, that is called subtractive kind of manufacturing. So then after manufacturing, it will be sending to the market, and after that also market analysis will be done, like for product, like how much life lasting, like it will be taken review from the customers, that how much life lasting it is taking, or it is effectively done or not, so that we can have a reverse engineering on that. We can generate new products of the same product. So with this we have learned about the product designing process. So with this, thank you, have a great day and keep learning.